In this video, we're going to have a look at distance, speed and time and how to do different calculations. So, you're probably familiar with the distance, speed, time triangle. I kind of tell my people to remember it's Downing Street where the Prime Minister lives to help us get the order. If we want to figure out distance, what we would do is we put our finger over the letter D and we'll be left with S and T and they'll be on the same level. To work out distance, we do speed times time. See if we put our finger over the letter S, D and T are on different levels, so we would write down S equals D over T, distance divided by time. If we wanted to work out time, I'd put my finger over the letter T, I would do distance divided by speed. We're going to use these formulas, which are kind of assumed as known, to do some calculations. We'll start off basic and then we'll build it up. Okay, so let's have a look at the basics. A car travels 30 kilometers an hour for 6 hours. How far did it go? I like to get my pupils to write down D equals, S equals, T equals, just so they can get an idea of what we're looking for here. So you want to figure out how far did it go. It went 30 kilometers an hour, and it did that for 6 hours. Okay, and as we said, to work out the distance, we're going to do speed times time. So we're going to do 30 times 6, which is 180, and the unit of measurement here will be kilometers. Number 2, a ball covers a distance of 10 meters in 2 seconds, calculate its speed. So for me, every question starts off D, S and T. So it goes 10 meters, we want to work out the speed, it does that in 2 seconds. So our formula is we're going to do speed equals distance divided by time. 10 divided by 2, which is 5. What's our unit of measurement? Well, this time it's going to be meters per second, and we're just taking that off the distance and the time here. Number 3, a van goes 180 miles at a speed of 45 miles per hour. How long did this take? So you'll notice once again everything starts the same, D, S and T. So it goes 180 miles, 45 miles per hour. We want to work out the time. To work out the time, we do distance divided by speed. So we're going to do 180 divided by 45, which is 4. What's my unit of measurement here? Well, it's going to be 4 hours. Okay, so those are just the basics behind speed, distance and time. We can develop this a bit further though and take this into decimal time. And the biggest thing we need to be able to do here is to convert between minutes and hours. So if we have 60 minutes, we know that that is 1 hour, which we divide by 60. If we have 1 hour, well, that's the same as 60 minutes. So we need to be able to do this conversion because often when we're doing calculation, we want it to be in terms of either hours only or hours and minutes. I'll show you what I mean. A cyclist travels at a speed of 40 kilometers per hour for 2 hours 15 minutes. How far did it go? Okay, this looks the same. D equals, S equals, T equals. How far did it go? That's distance. The speed, 40 kilometers per hour. And that's 2 hours and 15 minutes. Can I tell you what 2 hours and 15 minutes is not? It is not 2.15 hours. That is wrong. It's not 2.15. It would be 2.15 if there were 100 minutes in an hour, but there's not. There's only 60 minutes in an hour. So what we need to do is we need to convert this 15 minutes. And like we say, to go from minutes to hours, we're going to divide by 60. So to change the time, we're going to do 2 plus 15 divided by 60. And we can just type that into our calculator. 2 plus 15 divided by 60 is 2.25 hours. You may have been able to do that off the top of your head because 15 minutes is a quarter of an hour, a quarter is 0.25. So there it was important, we had to change it to decimal time. We can't have hours and minutes as part of our calculation. We need decimal time. It's not 2.15, we had to divide by 60. So we'll do speed equals, distance equals speed times time. We'll do 40 times 2.25. Typing that into our calculator, we are going to get 90. And that's going to be 90 kilometers. Okay, so really important part here. Okay, number 2. A car travelled 300 kilometers at a speed of 125 kilometers per hour. How long did this take? So D equals, S equals, T equals. So I've got 300 kilometers, speed 125 kilometers an hour, time question mark. So we'll work out the time, we'll do distance divided by speed, 300 divided by 125, and that's going to be 2.4 hours. I'll tell you what this is not. This is not 2 hours 40 minutes. It is not 2 hours 40 minutes because there are not 100 minutes in an hour. What we need to do is we need to change this 0.4, okay, because we know that there are 2 hours. There are 2 hours, okay, we want to figure out how many minutes there are. We've got 0.4 of an hour. So what we're going to do is we're going to do 0.4. So we want to go from hours to minutes. From hours to minutes, we're going to times by 60. So we're going to do 0.4 times 60. And that's going to lead to 24. So therefore, the time is 2 hours and 24 minutes. Okay, so decimal time, we can make it a little bit harder. The final thing we're going to talk about is distance time graphs. We can represent journeys via a graph. Okay, so we can look at this in different sections. We'll maybe call this part section 1. I'll actually make that a bit thinner. We'll call this part section 1 here. So what can we say has happened? Well, do you notice that in this first little section, we went 2 hours, or it took 2 hours, and we went 30 kilometers. So see, for this first section, we could work out the speed. For that first section, we could do speed equals distance divided by time, because we could do 30 divided by 2, because we went 30 miles and we did it in 2 hours. So see, for that pink section, we were travelling 15 miles per hour. If I change the colour of my highlighter here, let's go a light green. In this second section, I'll do here. Hopefully you can see that it just took this section, just lasted 1 hour. And how far did we go? Well, we started at 30 and we went to 50. So for the green section, we could do speed equals distance divided by time. And for the green section, well, the distance, we went from 30 to 50. So that's going to become 20 divided by 1. So in the green section, we did 20 miles per hour. A big feature though is, do you notice that we have this section here represented by a horizontal line? And that horizontal line is taking place in between hours 3 and 5. So do you notice that after 3 hours we are 50 miles away? And after 5 hours we are also 50 miles away. Therefore, between hours 3 and 5, we have not moved. We have not moved. Maybe our journey has stopped. Or we could maybe say we are stationary. Okay. Last thing, we'll say, I'll go this colour here. Do you notice this line going back down? So see, when a line goes back down to the x-axis, this one here, that means we're returning back to where we started. Okay, so from hours 5 to 6, we have travelled 50 miles in 1 hour. Okay, because we went from hours 5 till 6, and we went all the way from 50 back down to 0. So we went 50 miles. Do you notice that this line here is the steepest? Steeper lines indicate quicker journeys. Okay, so the steeper the line, the faster the journey. And that is a bit of a whirlwind through speed, or distance, speed and time. Thanks very much.